Hello, this is Mr. Collier, and today we're doing conditional probability. So this is basically how it works. This is the notation. It's basically when we're given a piece of information, it kind of changes the probability a bit, which we'll see lots of examples of today. So it looks like this: A, vertical line, B, that means the probability of A knowing B has occurred, or the probability of A given B. Often we'll see the word given, or some other wording, but basically we're given a piece of information. So the given thing is always after the little vertical bar, so it reads probability of A given B. Okay, and here's a formula for it, and you'll see why it works in a second when we do some Venn diagrams and tree diagrams. It's always equal to the probability of A and B happening divided by the probability of B. Okay, so basically what happens is you kind of change the denominator to a smaller subset. Okay, just a subset of where B happens, which will make sense when you see some Venn diagram questions later. And this is a Venn diagram question, so we'll see that now. We can make a Venn diagram for this because there's two fruits, banana and pineapple. So let's draw a Venn diagram. Banana, pineapple. Two dislikes, so we can have two outside of there. 40 like bananas, 22 like pineapple, but there's 40 total. Okay, now there's 34 like bananas, 22 like pineapple, but some of them like both, so we don't know exactly where to put these numbers. But they all have to add up to 40, so you can do 40 minus 2, that gives you 38, should be inside the two circles. Then you can minus 34, and then minus 22, and end up with something like negative 18. So that means it should be 18 in the overlap. Okay, there should be 18 in the overlap. So that means that there's 34 that like banana. There's got to be 16 right here, because 16 plus 18 is 34. 22 like pineapple, and then we have 4 here. You can double check now, and all these numbers add up to 40. These add up to 34, these add up to 22. So it all works out. So the probability that some random person from this group likes both fruits, so that's the probability they like banana and pineapple, is, well, you can count here and just count up how many like both of them. Well, it's 18. It's right at the intersection. So it's 18 out of 40, which is 9 over 20, which is 4.5 over 10, which is 45 out of 100, which is 45% if you like percents, or you can leave it as a fraction. Number B likes pineapple given that he or she likes bananas. Okay, we can use the formula, and then I'm also going to show you in the diagram. So the formula says pineapple and bananas, which is our answer from part A, divided by probability of bananas. So our answer from part A is 45 out of, let's write it like this. It was 18 out, I'm going to use the unsimplified version, sometimes that's a bit more useful. Probability of banana is 34 out of 40. So keeping it out of 40, I see the 40s cancel. If I multiply numerator and denominator by 40, they just cancel. So it's 18 out of 34, which equals 9 out of 17. Okay, you can see that from the diagram too, because if we know they like pineapples, then we're just looking at these 30 sorry, I'm looking at the wrong question. If you know they like bananas, then we're looking at just these 34 people. That's why the denominator is 34. We're just looking at those 34 people, and there's 18 of those like bananas, so that's why it's 18 out of 34. So for Venn diagrams, you don't really need the formula, but for some more complicated questions, you definitely need the formula. So for part C, it is probability dislikes bananas given that he or she likes pineapples. So it's the same as probability of not B and P divided by probability of liking pineapples. Okay, so that equals probability of not liking B and liking pineapples. So that's the 4. 4 people like pineapples and don't like bananas. So that's 4 out of 40 is that probability. And the probability of liking pineapples is 22 out of 40. Okay, that equals 4 out of 22, which equals 2 out of 11. Alright, and as a percent, that is 18 out of 99, so it is approximately 18.18%. Okay, so you can also get that from just from the Venn diagram. Because if they like pineapple, we're just looking at these people. So the denominator is 22, and the numerator is 4. Okay, let's look at probabilities from a table. We got male, female, French and German choice of language for classes, and then we got some totals on the side. So the probability that a random person likes French or takes French is, well, there's 130 French students, and there's 200 students in total. So that is 65 out of 100, or 65%. Probability of male, we just need the total number of males. So that's 80. That's 40 out of 200, 40 out of 100, which equals 40%. And let's do part D up here. Probability of female given they do French. Oh, I'd used F for both. Let's use FR for French and FE for female. So we can use the formula, or we could just logically do it. Your denominator is the number of people that take French, because we're given that they take French. So the denominator is this one. Okay, and how many of those are female? It's 40. So it's just 40 out of 130, or 4 out of 13. So for part E, or did we skip one? I did skip one. Okay, let's just go on to part E. Doing German, given that he is male, so you're probably a German given male. We're just looking at the male students, so it's 80 in the denominator. And how many of those German is 40? So that is just half, or 50%. Okay, and of course this one here, part C, probably a male and doing German. Well, there's 40 German males, so it's 40 over 200, which equals 20 out of 100, which equals 20%. Okay, now this is a tree diagram question. So I'll draw a tree diagram, and in this case, yeah, the formula is most useful for these tree diagram questions, really. Okay, so I'll draw the tree diagram right over here. Or, yeah, maybe right here, it'll give me some more room. Okay, it's probably a rain on Monday is 3/5. So we'll call this rain and no rain. 3/5, 2/5. And on Tuesday we have rain, no rain, rain or no rain. So on Tuesday, if it rains on Monday, then the probability is 4/5 on Tuesday. So that's 4/5. There's 1/5, right? Because it either rains or don't rain. So they have to add up to 1. And for this one, it should be 3/5 and 2/5. So for part A, probably it rains at least once. At least once. That is the probability. It rains, it doesn't rain on Tuesday, or it doesn't rain on Monday, but it rains on Tuesday, or it rains both days. But that is the same as 1 minus the probability it doesn't rain both days. Okay? 1 minus the probability, because we only need to calculate one probability here. That's 2/5 times 2/5, which equals 1 minus 4 out of 25, which is 21 out of 25, which is 84 out of 100, or 84% chance. Okay, so that's part A. Part B, it rains only one day, so that is probability of rain and no rain, plus probability of no rain, rain. Or you can take your answer from part A and then subtract this probability, you get the same thing. Anyway, rain, no rain is 3/5 times 1/5. No rain, rain is 2/5 times 3/5. So that is 3 plus 6 is 9, so we have 9 out of 25, which equals 36 out of 100, or 36% chance. Okay, and the last one, it rains on one day only, given it rains only once. So this is conditional probability. Probably it rains once only, given rains at least once. Okay, that is probably it rains once only and rains at least once divided by probability it rains at least once, the second thing, right? Okay, so I usually start with the denominator. Okay, so probably it rains at least once. That's your answer from part A, which was 21 out of 25. Probably, now sometimes you gotta think logically about this part. Probably it rains once only and rains at least once. Well, if it rains once only, that is at least once, so that's kind of redundant. So it's the same as probability it rains once only. And that is our answer to part B, which was 9 out of 25. Okay, so that probability is 9 out of 21, or 3/7. The teacher oversleeps with probability of 0.3, so he, how should we do that? He oversleeps. Let's call it S for oversleeps, and then doesn't oversleep. Okay. Now we have probability of breakfast and not breakfast. Okay, so teacher oversleeps with probability of 0.3, and I guess that means 0.7 here for doesn't oversleep. Then the probability of him eating breakfast is 0.2, and this one's 0.8. Otherwise, it's 0.6, and this is 0.4. So we have the tree diagram done. I'll do part A first. Probability he oversleeps and does not eat breakfast is equal to probability he oversleeps. Sorry, that's right. That is just this branch right here, which is 0.3 times 0.8, which equals 0.24, or 24%. Does not have breakfast. That is, we gotta add the other two branches here, because he could oversleep and not eat breakfast, or he could not oversleep and not eat breakfast. So we have to do 0.3 times 0.8, which we have from before, plus 0.7 times 0.4, which is 0.24, plus 0.28, which is 0.52, or 52%. So in part C, he oversleeps given he has breakfast. Okay, so maybe I'll do that down here. He oversleeps given that he has breakfast equals probability he sleeps and has breakfast, oversleeps and has breakfast, divided by probability of breakfast. Now we have the probability he does not have breakfast. That's the answer to part B, right? So to get the probability he has breakfast, it's 1 minus that answer. Now the probability he oversleeps and has breakfast is 0.3 times 0.2. Okay, so that equals 0.06 over 0.48, which is 6 over 48. That is the same as 3 over 16. Okay, and the last question is, probability he oversleeps given he does not have breakfast. Okay, so that's going to be in your denominator. You're going to have probability does not have breakfast. In your numerator, probability he oversleeps and does not have breakfast. So your denominator is actually 0.52. We did that one earlier. And oversleeps and does not have breakfast is your answer from part A, which is 0.24, which is going to be 24 out of 52, which equals 6 out of 13.